Welcome everybody. We're going to take a look at the 2018 AP Calc AB FRQs number 4 through 6 in this video. So we're going to jump in and get started with number 4. So let's see, we're given a table. The question says the height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. So just real quick, some important information that we need to be aware of are our function that we're talking about is twice differentiable. H of t is in meters and time is years. So that's all good stuff to keep in mind. Now for part A, it says use the data in the table to estimate h prime of 6. Using correct units, interpret the meaning of h prime of 6 in the context of the problem. So if we want to approximate a derivative from a function using a table, then what we're going to do is use the slope of the secant line, all right, using points closest to 6. So we're going to need to use the value at h of 7 and h of 5. So for part A, we're going to approximate the derivative for h prime of 6 using h of 7 minus h of 5 over 7 minus 5. Again, that's the slope of the secant line, so that's going to be 11 minus 6 over 2, which is 5 halves. So h prime of 6 is 5 halves. Now, it does ask us to interpret the meaning of h prime of 6 in the context of the problem. So what this would mean is at time t equals 6, the height of the tree is changing at a rate of 5 halves meters per year. And that would suffice that answer. All right, now, if we go and we want to take a look at part B. Part B says, explain why there must be at least one time t for t greater than 2 and less than 10 such that h prime of t equals 2. All right, so I'm trying to think here. We're trying to show the derivative equals a certain value. In my mind, the only thing we really have to help us with that is the mean value theorem, which says that if a function is continuous and differentiable, then the average rate of change is equal to the instantaneous rate of change at some point on that interval. All right, well, if I start and I just look at 2 to 10, right? So we would have 15 minus 1.5, that's 13.5, divided by 10 minus 2. So 13.5 divided by 8, that's not going to get us 2 that we want. So what we can do is we can try to look at subintervals and see if any of those average rates of change equal 2. So, just kind of a quick look, 2 minus 1.5, that's a half. Half divided by 1, that's not going to work. If we look at from 3 to 5, 6 minus 2 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. All right, so there we go. If we take h of 5 and we subtract h of 3, we end up with 6 minus 2 divided by 2, which is 4 divided by 2, or 2. All right, and basically, since h of t is differentiable, it is also continuous. So on the interval, let's see, t greater than 3 but less than 5, there exists a value c such that h prime of c is equal to h of 5 minus h of 3 over 5 minus 3. Therefore, h prime of c equals 2 at some point on the interval t greater than 3 and less than 5, which is a subinterval of the interval that was given, which was t greater than 2 and less than 10 by the mean value theorem. So we want to make sure we include the MVT. Now, the wording can be slightly different, all right, but the idea is we're trying to verify that the derivative at some point on the interval equals 2. So we have to find an average rate of change within that interval that equals 2 so that we can apply the mean value theorem. And again, in order for that to apply, the function has to be continuous on the closed interval and differentiable on the open interval. And at the beginning of the problem, it told us twice differentiable, so we know that that function is differentiable. All right, now looking at part C wants us to use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over the interval from 2 to 10. Average height. This is where you got to kind of think about, what are we given? The function h of t represents the height. So if we want the average height, that really means we want average value. So the average value formula that we learned, 1 over b minus a times the integral from a to b. In this case, it would be of h of t dt. That's average value. So in this particular example, that's what we're going to use. So we want the average height from 2 to 10. So it's going to be 1 over 10 minus 2 times the integral from 2 to 10 of h of t dt. The problem is telling us to use a trapezoidal Riemann sum with 4 subintervals. So your subintervals are going to go from 2 to 3, 3 to 5, 5 to 7, and 7 to 10. Well, from 2 to 3 is a width of 1, from 3 to 5 is a width of 2, 5 to 7 is a width of 2, 7 to 10 is a width of 3. The widths are not the same, which means you're basically going to find the area of each trapezoid individually and just add them together. So what I'm going to do is I'm going to go ahead and I've got 1 over 8 times. Now, the one thing that will be consistent for all of these trapezoids is the 1/2. Again, area of a trapezoid. We kind of write this off to the side here. So area of a trapezoid is 1/2 the height times base 1 plus base 2. The height is the width in this case. So they're all going to have that 1/2. So you could, in theory, just pull that 1/2 out with the 1 over 8 and then multiply it basically by the height times the sum of the bases for each trapezoid. So for the first trapezoid, the height's going to be 1, and your bases are 1.5 and 2. 1.5 plus 2. Plus, for the second trapezoid, your height is 2, and your bases are 2 and 6. So 2 plus 6. For the third trapezoid, your height is 2, and your bases are 6 plus 11. And finally, for the fourth trapezoid, your base or your height is 3, and the bases are 11 and 15. All right, at that point, you've really found the trapezoidal Riemann sum, and if you left it like that, you would get full credit on the exam because you don't have to finish arithmetic. But I'm going to go ahead and finish this. So we have, let's see, this is going to be 1 over 16, and then in parentheses here, let's see, 1.5 plus 2, that's going to be 3.5, plus 8 times 2, that's 16. 17 times 2, that's 34. And then 26 times 3, that's 78. All right, and if we add all those together, we should end up with 263 over 2, which is 263 over 32. And again, because we're talking about average height, it would be meters. You don't have a calculator, you definitely don't need to worry about a decimal answer. But right here, you know, because of the time issue on the AP exam, that really would get you full credit for the problem. All right, guys, moving on to part D. Let's take a look at what that says. All right, so part D says the height of the tree in meters can be modeled by the function g given by g of x, which is equal to 100x over 1 plus x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.3 meters per year. According to this model, what is the rate of change of height of the tree with respect to time in meters per year at the time the tree was 50 meters tall? All right, a lot of wording going on in that problem, but when you start to see, you know, the rate of change of the diameter, the rate of change of height, this is a related rates problem. So now, what we know, let's see, it says the height of the tree is given by this function, g of x. So let me kind of get this out of the way here. All right, so the height of the tree, g of x, is 50. We also know that g of x is being modeled by this equation, 100x over 1 plus x. We know when the tree is 50 meters tall, the diameter, all right, so the change of diameter with respect to time is 0.03 meters per year. And we want to know the rate of change of height. So the rate of change of height is essentially going to be dg dt, because g of t represents the height of the tree. All right, so let's kind of think about some things that we're going to need to know. We have these two expressions where g of x is equal to 50 and it's equal to 100x over 1 plus x. So let's set those equal. So different color. So 50 is equal to 100x over 1 plus x. So if we cross multiply, we're going to get 50 plus 50x equals 100x. 50 equals 50x, so x equals 1. All right, that's probably going to come into play here. We know that x is 1. We're going to need to find dg dt. So if we go to find dg dt, we have dg dt equal to, we're going to take the derivative of this. So we've got 100, derivative of the top is 100. All right, dx dt times the denominator, 1 plus x, minus the derivative of the denominator, which is 1, dx dt times 100x over the denominator squared. One thing that we have is we've got these unknowns of dx dt and x. We said x was 1. Now, earlier I wrote that the rate of change of diameter with respect to time was 0.03. If you go back and look at the problem, it tells us that x is the diameter of the tree. So really, we should have written this as dx dt. All right, and at that point, it's just a matter of substituting in and solving. So we have 100 times dx dt is 0.03. 1 plus x, that's going to be 2, minus 0.03 times 100 over basically 2 squared. because 1 plus 1. So let's see, 100 times 0.03, that's 3 times 2, so 6 minus 0.03 times 100 is 3 over 4. You get 3 over 4. So dg dt is going to be 3 over 4. So the rate of change of the height of the tree is 3/4, and it's meters per year. All right, and that is how you would go about and finish part D of that FRQ. Again, you got to recognize that it's a related rate problem and set everything up correctly. All right, let's go ahead and move on and take a look at number 5. So for number 5, it says to let f be a function defined by f of x, which is e to the x times cosine of x. Part A is find the average rate of change of f on the interval from x is greater than or equal to 0 and less than or equal to pi. Now, average rate of change means slope of the secant line. So for part A, we basically are going to need f of pi minus f of 0 over pi minus 0. All right, that's how we're going to find the average rate of change, is slope of the secant line. So I'm going to do a little bit of work off to the side here. In order for us to find f of pi, we have e to the pi cosine of pi, and cosine of pi is -1, so this is negative e to the pi. And if we calculate f of 0, we have e to the 0 cosine of 0. Well, cosine of 0 is 1, e to the 0 is 1, so this is 1. So what we end up with is negative e to the pi minus 1 over pi. And that right there is the average rate of change on that interval. Now, guys, it is important that you have this. You want to have that expression written to show them that you are finding the slope of the secant line. You can't just have these values appear out of nowhere. So you want to set this up. You have your difference quotient is what that's called. And then you calculate the values and you have your answer. All right. Now, for part B, let's take a look at what part B says. Part B is what is the slope of the tangent line of the graph at x equals 3 pi over 2. So the slope of the tangent line at 3 pi over 2 is going to be equivalent to the derivative at 3 pi over 2, because that's what the slope of the tangent line is. Okay, slope of the tangent line is f prime. So first thing we're going to do is we're going to calculate the derivative of f. So f prime of x is derivative of the first, e to the x, times the second, cosine of x, plus the derivative of the second, which is going to be negative sine of x, times the first, e to the x. From there, we are going to calculate the derivative at 3 pi over 2. So we want f prime of 3 pi over 2. So that becomes e to the 3 pi over 2 cosine 3 pi over 2 minus sine 3 pi over 2 e to the 3 pi over 2. And if we simplify that down, cosine of 3 pi over 2, that is 0. So this becomes 0 minus sine of 3 pi over 2, that's going to be -1 times e to the 3 pi over 2. So if I have 0 minus -1 e to the 3 pi over 2, that is e to the 3 pi over 2. So the derivative, or the slope of the tangent line at 3 pi over 2 is e to the 3 pi over 2. So you want to make sure you have the derivative, and then you want to make sure you show that you're plugging into that derivative to get your final answer. All right, looking at the next part of this, Part C says find the absolute minimum value of f on the interval x is greater than or equal to 0, less than or equal to 2 pi. Justify your answer. So absolute minimum, all right, we want to think candidates test, closed interval test, however you want to look at it. But what we need to identify is we need endpoints and we need critical values. So we need to know for part C when f prime of x is equal to 0. So we found f prime of x, which is e to the, whoops, let me kind of write this. Oh yeah, it's e to the x cosine of x minus e to the x sine of x. And we want that to equal 0. So some things we can do quickly is we can factor out the e to the x. So e to the x is going to be taken out, and you have cosine of x minus sine of x, and that needs to equal 0. And if you just think about what you know about e is always positive, okay? It's got a horizontal asymptote at 0, it's always positive. So that's never going to equal 0. So the only way that this equals 0 is if cosine of x minus sine of x equals 0, which means that cosine of x has to equal sine of x. All right, and we're looking at the interval from 0 to 2 pi, and cosine of x is going to equal sine of x when x is equal to pi over 4, and also 5 pi over 4. So it's at quadrant 1 and quadrant 2 when that reference angle is pi over 4. All right, from there, what we're going to do is we have to basically do our candidates test, and we have to figure out where does the minimum value occur. So we're going to use endpoints, which were 0 and 2 pi, and critical values, which are pi over 4, and whoops, it's supposed to be 5 pi over 4. All right, so from there, we are plugging back into the original function. So if you plug in 0, right, this is basically e to the 0 cosine of 0. Well, e to the 0 is 1, cosine of 0 is 1, so that's 1. And then we have basically e to the pi over 4 cosine of pi over 4. So that's going to be e to the pi over 4 times root 2 over 2. And then if you have e to the 5 pi over 4, keep forgetting that pi, 5 pi over 4 times cosine of 5 pi over 4, you have e to the 5 pi over 4 times negative root 2 over 2. Because you're in that quadrant. And then if you plug in 2 pi, you've got e to the 2 pi cosine of 2 pi. Cosine of 2 pi is 1, so this is e to the 2 pi. So at that point, the absolute minimum is going to happen right here, okay? So you would say that the absolute minimum is f of 5 pi over 4, which is equal to e to the 5 pi over 4 times negative root 2 over 2. All right, and the way, and I probably should have kind of spent a little bit more time on this, but the way we know that that is the minimum value is it's the only value that's negative. Every other value here is positive. Okay, so even though we don't know the exact value of e to the 5 pi over 4 times negative root 2 over 2, it's the only negative value, which means it has to be the smallest. All right, but again, absolute is what's telling us we need to include endpoints in that answer. All right, and if we move on and we take a look at part D, all right, let's see what part D says. It says, let g be a differentiable function such that g of pi over 2 equals 0, the graph of g prime, which is the derivative of g, is shown. Find the value of the limit as x approaches pi over 2. So we want the limit as x approaches pi over 2 of f of x over g of x. Or state that it doesn't exist. All right, so let's see. Limit of a quotient, and then they gave us this piece right here that g of pi over 2 is 0. You know, that's probably giving us a clue about something. So again, what you would do is you would plug in pi over 2, right? And we know that g of pi over 2 is 0. Well, let's go ahead and figure out what f of pi over 2 is. Well, we didn't find that quite earlier, but if we go back up to f, sorry, I'm kind of all over the place, but f of pi over 2 is going to equal e to the pi over 2 times cosine of pi over 2. Well, cosine of pi over 2 is 0, so that's 0. So right now, what that tells us is this is L'Hopital, okay? Indeterminate form, L'Hopitals. That's what we're going to use. So that means that this is going to be the same thing as the limit as x approaches pi over 2 of f prime of pi over 2 divided by g prime of pi over 2. All right. Well, f prime of pi over 2, again, if we plug back into our formula over here, just kind of bear with me right here, but if we plug in pi over 2, cosine of pi over 2 is 0 minus sine of pi over 2, so that's 1. So this is going to be negative e to the pi over 2. So this is negative e to the pi over 2. And then for g prime of pi over 2, well, here is the graph of g prime. Here's pi over 2, so it's 2. So therefore, the limit is going to be negative e to the pi over 2 divided by 2, and that would be your answer. All right, and again, guys, it's just about figuring out how all these pieces that they give you fit together, you know, reading the question to decide what do you do first. All right, guys, we'll go ahead and take a look at the last one here, number 6. So for number 6, we are looking at a differential equation where dy dx is equal to 1/3 of x times y minus 2 quantity squared. Part A says a slope field for the given differential equation is shown below. Sketch a possible solution curve that passes through the point 0, 2, and sketches the solution curve that passes through the point 1, 0. All right, so if we are going to have a solution curve that passes through the point 0, 2, all you're going to do is find 0, 2 on your graph and follow the slopes. Well, this is a horizontal line that looks like this. That is your solution curve there. For the other one, you want a solution curve that passes through the point 1, 0. Well, here is 1, 0 right here. So again, what you're going to do is try to follow those slopes as best you can. And it's going to look something, well, I didn't do a great job of kind of coming back up, but it's going to look something similar to that. So find the point, you find the point that they want, and then you just have to try to follow the given slopes as best you can. Okay. All right, for part B, let y equal f of x be the particular solution to the given differential equation with the initial condition f of 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. And then you want to use your equation to approximate f of 0.7. All right, so let's think about this. Write an equation of a tangent line. In order to do that, we need slope and a point. Okay, so we need slope and a point. That's what we need. So they give us this point right here. You're given the point 1, 0. The slope is going to come from the derivative, right? Well, the derivative was given to us right here. So the slope is going to be found by evaluating our derivative at that point, which is 1, 0. So what we're going to do is we're going to go ahead and plug in. We have 1/3 of x is 1, y is 0 minus 2 quantity squared. So this is 1/3, and negative 2 squared is 4, so that's 4/3. So the equation of our tangent line, y equals, our slope is 4/3 times x minus our point 1 plus 0, basically. And then from there, we want to use that. So this, I should probably wrote this down. This is the equation of the tangent line. And then we need to use that equation to approximate the value of the function at 0.7. So let's see, we've got y equals 4/3 of 0.7 minus 1. So 4/3, now 0.7 minus 1, that's negative 0.3, so negative 0.3, which is the same thing as negative 3/10. So basically, whoops, what I wanted to put here was y of 0.7. So now y of 0.7 is going to be approximately, well, your 3's are going to cancel, and you can reduce the 4/10 to negative 2/5. And negative 2/5 would be your approximation. So, information sometimes is given to us in different ways. But anytime you want to write the equation of a tangent line, you've got to know slope and you've got to know the point. The slope comes from the derivative evaluated at that point. Okay, the derivative of the function at a point is the slope of the tangent line at that same point. So you got to be looking for those pieces of information. All right, now the last part of this is for us to find the particular solution to y equals f of x to the given differential equation with the initial condition. So we need to solve in part C, try to get this over here. We need to solve this differential equation. So dy dx is 1/3 of x times y minus 2 quantity squared. So if we're going to solve this, we're going to use that separation of variables technique, where we want to get the y's with the dy's and the x's with the dx's. In doing so, all right, we're going to basically divide by y minus 2 quantity squared. So 1 over y minus 2 quantity squared dy equals 1/3 of x dx. From there, we are going to integrate. All right, so we need to integrate both sides of this function. Now let's focus over here real quick. I'm just going to go ahead and rewrite this as y minus 2 to the negative second dy. All right, and then I'm just going to leave this as 1/3 x dx for a second. And when you integrate this, if I use u substitution, I could let u equal y minus 2. So du is dy, right? And that's all we get there. So that means that there's not a whole lot to that u substitution. And if you recognize that, all you could replace it with u, but then you're just going to put y minus 2 back in place of u. So as we do this, we're going to increase the power by 1. So we're going to take that y minus 2 and add 1 to get negative 1. And then we're going to multiply by the reciprocal, which is negative 1. Over here, all right, we are going to add 1 to get x squared, and then multiply 1/3 by 1/2 to get 1/6 plus c. And that's kind of where we're at that point. If we start to simplify some of these things down a little bit, this is negative 1 over y minus 2 equal